There are two other very important distributions called a Bernoulli distribution and a binomial distribution. Okay, I'm on the Wikipedia page for the Bernoulli distribution right now. Both these distributions are discrete distributions, and let's understand what they are. Okay, suppose if I have a coin toss. Suppose I have a coin toss. Okay, and let's assume a coin toss. Okay, when I toss a coin, I can get either heads or tails. Right, I can get two values. And what is the probability of getting any of these values? What is the chance of getting a head? It's 0.5. What is the chance of getting a tail? It's also 0.5, right? So so for a Bernoulli distribution is used when you have two outcomes. Okay, when you have two outcomes and the probability of getting one outcome is P. Probability of getting the second outcome obviously is 1 minus P. Okay, so Bernoulli distribution is a distribution which has two outcomes, literally has only two outcomes. So if you see the description here, which takes the value 1 with probability P and value 0 with probability Q, which is 1 minus P. Okay, so the probability, so of course here if you notice it's written as probability mass function because it's a discrete random variable. So the parameters of a Bernoulli distribution are P. Okay, so you basically say whenever a random variable X is Bernoulli distributed, right, you basically say it's Bernoulli P. If you say Bernoulli P equals to 0.5, this is exactly like your coin toss. Because there are only two outcomes, heads and tails, right? If I say heads as 1 and tails as 0, the probability of getting 1 is half, probability of getting 0 is half. Okay. Suppose if I have a biased coin, okay, which means it doesn't always do heads and tails with 50-50% probability. Let's assume it generates heads, which is equal to 1 with a probability of 9.9, and tails, which is a value of 0 with a probability of 0.1. Okay. Suppose somebody built a biased coin by changing the weight of the coin on one side and things like that, right? Like some of your fancy movies out there, which always generates some heads more times than tails. I think it was Sholay movie, if I'm not wrong, where the primary character, if I'm not wrong, Amitabh Bachchan has a coin. Again, it's been years I've watched this movie, where when you toss a coin, the chances of getting a head are significantly more. I think it's always 100%. It's been many years I've watched that movie, so excuse me if there are any inaccuracies in that. Okay, so having said that, now let's come back to our Bernoulli distribution. Bernoulli distribution has a PMF, which is its value is Q, which is its only parameter is P, and of course remember P has to be less than or equal to 1. Sorry, strictly less than 1, and it should be strictly greater than 0. Okay, and your P and Q are the probability of getting 0 is Q, probability of getting 1 is P. Okay, you might say, why is Bernoulli distribution useful? Please bear with me. All these distributions will play a very interesting and important role as we go forward when we learn more important probabilistic ideas and also techniques in machine learning. I'm just introducing a concept here. I promise you we will reuse all of these concepts later. Okay, so what is the probability mass function for a Bernoulli distribution? It's whenever for k equals to 0, its probability is Q. For k equals to 1, its probability is P. Right? So if I have to literally write it, if I have to draw it, since it's not drawn here, let me go attempt to draw it. Okay. So imagine if I have two values, I have value of 0 or 1. It can take only two values, right? It can't take any other value. So this height, let's assume is Q. Okay, so I have a point here. Let me change the color here. I have one point here. I have another point here. Okay, and this value will be P. Okay, there are only two outcomes, 0 or 1, and such that P plus Q equals to 1. That's very, very important. Okay, because there are only two values, the probability should sum to 1. This is what you'll see as the probability density function of, sorry, my mistake, the probability mass function of a Bernoulli random variable. Okay, since it's not drawn here, I thought of a Bernoulli distributed random variable. There are only two outcomes here. If it was a coin toss, both these P and Q will be equal to 1. Okay, the only thing is P and Q should sum to 1. So the plot could look like this, or the plot could look like this. Okay, it could look like anything except that these two values should sum to 1. That's the only constraint. Okay, having said that, let's move down. So Of course, it's very easy. The mean of a probability of a Bernoulli distributed random variable is P itself. Okay, and there is an equation for variance which is P into Q and things like that. We will reuse them when we have to later, significantly later in our discussion about machine learning algorithms, especially the probabilistic variety. Now, since we learned about Bernoulli random variable, there is another random variable called a binomial random variable, which is very related. Okay, so a binomial random variable and a Bernoulli random variable are related as follows. Okay, so let me explain you this. Suppose if I have my coin toss. Okay, suppose let's assume this is my Bernoulli. Okay, with 0.5, with p equals to 0.5. Okay, now if I do, so this is nothing but coin toss, right? This is nothing but coin toss, a fair coin toss, fair coin toss. Now, if I toss this coin n times, okay, suppose let's assume I toss this coin 10 times. So let's say n equals to 10. Let's just say, please bear with me. Okay, now the question is, how many times, suppose I want to create a new random variable y, which is number of times I get a head, when I toss my fair coin, n times. So this is important. It's very, very important to read this. Y is a new random variable that I'm creating, which is number of times I get a head when I toss my fair coin n times. If let's assume n equals to 10, what is the maximum value of y? See, then y can be 0. I might get 0 heads, right? When I toss a coin 10 times. Of course, it's very less likely, but it's possible. Or I might get 1 head, or I can get 2 heads, or I can get up to 10 heads. Of course, getting 10 heads is very less likely. Okay, right? So this random variable y, now we say y is distributed with a binomial distribution, and it has two parameters, n and p. P is the probability value in the Bernoulli which is generating this binomial. N is the number of trials, or number of coin tosses, or number of trials. It's called number of trials or number of coin tosses. This is probability of getting a head or one. You might say, why are we talking about coin tosses? Do we do it that often? Please bear with me. Both Bernoulli and binomial distributions have a very, very interesting applications when we learn probabilistic methods in machine learning. Okay, so is this clear? So if x is a Bernoulli random variable with value p, and if I repeat this experiment, if I do n trials of this, okay, then y is nothing but number of times I get a head when I toss my fair coin n times. Now y also has a distribution, right? That distribution is called a binomial distribution and has two parameters n and p. Okay, now let's go and understand. Okay, so what are the parameters of binomial distribution? N and p. N is called the number of trials, and p is called the success probability of each trial, and p of course lies between 0 and 1. Okay, the probability mass function is very interesting. Again, this is a discrete random variable, right? Like the coin toss example, it can take either 0, if I toss it, if my n equals to 10, right? My random variable y, which is binomial np, okay, can take values between 0 and 10. It can only take these 10 values, right? It can't take more or less values. It can't take 1.5 because it's not possible to get head 1.5 times, right? So the probability mass function is given using your idea in combinatorics, your combinations and permutations, right? This formula is very straightforward. What this says is, so suppose if I have to get k, if my value of y is k, okay, if my value of y is k, what is the probability that y equals to k? Of course, k lies between 0 and n, right? What is the probability? Which means the probability of y equals to k, the probability that y gets a value of k, of course, where k lies between 0 and n, is nothing but, okay, it is basically getting your heads k times, which is p par k, getting your tails n minus k times, which is 1 minus this, And that can happen in NCK ways. Okay, those of you who have studied combinatorics in your 12th grade will immediately be able to derive this. In case you cannot, don't worry, we will not use this extensively in machine learning. But if you know combinations and permutations, this is a simple exercise that you might have done in your 12th grade or undergraduate first year. Okay, this is simple basic combinatorics, and it's very, very straightforward to understand. Okay, having said that, I'll close out on both the Bernoulli and the binomial random variables. I'll not go into further detail because we do not need it right away. When we need it, we'll revisit this and learn it in more detail. I don't want to bore you with lots of theory. Okay, so this is the idea of both Bernoulli random variable and binomial random variables in probability.